Okay, let's talk about the airplane's engine. A fan at the front of the engine sucks the air in. The air that was being sucked in by the fan is now being compressed by the blades that are spinning at very high speeds. Fuel is sprayed at the compressed air, which sparks and lights up the mixture, which is a chemical change. By Newton's third law, which is action and reaction forces, the exhaust is shot at the back of the plane, which pushes the plane forward. There are many different kinds of forces acting on an airplane. Fluid friction or air resistance is acting against the plane, and gravity and weight is pushing downwards. Lift is pushing upwards, and thrust is making the plane go forward. Well, how does lift work? When the plane moves forward with high speed, air flows quickly over the tops of both of the wings, which makes the air go downward toward the ground. This creates a force called lift, which pushes the plane up. Next, let's talk about how the jet fuel was made. Jet fuel is the source of energy in an airplane. The jet engine burns the jet fuel with air in a chemical reaction known as combustion. Kerosene is very similar to jet fuel because they contain the same classes of hydrocarbons. The chemical equation of kerosene is CnH2. The Cn is a chemical symbol for copernicium and H is for hydrogen. Making jet fuel is a synthesis reaction. Jet fuel is mostly made out of liquid petroleum or crude oil. How do we breathe almost 30,000 feet into the atmosphere? This is because of pressurization systems. The main component is the jet turbine or the engine. So when this hot air was compressed, the oxygen molecules are pushed closer together. This is good for the jet because it needs a lot of oxygen to burn the fuel, but this also makes the air much more breathable for the passengers in the plane. Before the hot, oxygen-rich air is mixed with some of the fuel. Some of it is directed away from the engine, which is called bleed air. The bleed air is cooled and then released into the airplane cabins through the use of fans. This is how the interior cabin pressure is kept between 12 and 11 psi, good enough for us to breathe. Thermal expansion needs to be taken into account when designing a plane because airplanes are usually made out of crystalline solids such as titanium, aluminum, and steel. The larger the piece of metal, such as the airplane's wing or tail, the greater the contraction or expansion. The formula for thermal expansion is expansion equals coefficient times length times rise in temperature. Each substance has its own coefficient of expansion per degree Celsius. For example, aluminum's coefficient is 25 times 10 to the power of negative 6.